Reactivity of the halogen towards the hydrogen decreases from fluorine to iodine. The halogen and the oxygen do not combine directly with each other. However, this compound will be formed indirectly. The halogen, when it is react with the metal, it forms the halides. So, the oxidation of chlorine gas by the atmospheric oxygen in presence of copper chloride as a catalyst at 723 Kelvin, it gives rise to the chlorine. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called P block elements. Under this unit, we have discussed about the introductory part of the group 17 elements. In that, we have learned that what are all the elements which is belonging to the group 17, and also we have learned that general electronic configuration, occurrence and oxidation state and trends in their physical property. Very importantly, we have learnt about the anomalous behavior of the fluorine. Today, let us step up with the next topic of this unit by understanding the chemical properties of group 17 elements. So, in this, how does this group 17 elements reacts with the hydrogen or reacts with the water, and what will be the product we are going to understand. And we are going to understand the preparations of chlorine, which are the second elements in the group 17, and chemical properties of the chlorine and uses of the chlorine we are going to understand in this session. What are the chemical properties of the group 17? So, the first one is reaction towards the hydrogen. All these elements which is belonging to the group 17, when they react with the hydrogen, it gives the halides which are also known as hydracids. So, what does it form? When it is react with the hydrogen, it gives a halide, and that is also known as what? Hydra acids, and the reactivity of the halogen towards the hydrogen decreases from fluorine to iodine. As we move down the group, the fluorine, chlorine, bromine and iodine will be there. The reactivity towards the hydrogen will be decreases down the group, and these halides are dissolved in water to give a hydrochloric acids. For examples, you can see that the fluorine react with the hydrogen to form a hydrogen fluoride. Similarly, the chloride react with the hydrogen to form a HCl. Similarly, bromine react with the hydrogen to form a HBr, okay, hydrogen bromide, okay. And the acidic strength of this, of the group 17 elements will be in this order. You can see that this acidic strength which is going to be increases down the group. You can see that the hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. Hydrogen iodide has more acidic strength as compared with that of the hydrogen fluoride. And coming into their stability, you can see that how does this order will be decreases down the group. You can see that hydrogen fluoride is more stable as that of the hydrogen iodide. This is because of the decreasing in bond dissociation enthalpy, which means that if you consider from hydrogen to fluoride and between the hydrogen and iodide, the bond distances between the hydrogen and iodide which is so long, so that it is very easy to break this bond length. Whereas the bond length between the hydrogen and fluoride which is very small, so it is not so easy to break this bond. Hence this hydrogen fluoride, the stability will be very small because of the very small bond length. Okay, coming into their boiling point, you can see that how does this order will be goes, that hydrogen fluoride will have a higher boiling point as that of with the hydrogen chloride because of the stronger intermolecular hydrogen bonding. As the size increases, the van der Waals force of attraction which is also get increased, hence their boiling point which is also get increases as we move down the group. And coming into their ionic characters, you can see that from the fluoride, chloride, bromide and iodide, fluoride will shows the highest ionic characters, and also their dipole moment also you can see that it will be in this order. So hydrogen fluoride, again their dipole moment will be more and more. That is mainly because the electronegativity will be decreases down the group. Coming into their reducing power of the group 17 elements, you know, the HF will be least reducing in nature, whereas the hydrogen iodide are more reducing in their nature. Coming into their reactivity towards the oxygen. So the halogen forms oxides, but the fluoride will form two types of oxide, and it will be represented as OF2 and O2F2. Okay, among this only the OF2 will be stable at 25 degrees Celsius. That is mainly because as the fluorine is more electronegative than the oxygen, the oxides of the fluorines are also forms a more stable, okay, than that of the oxygen fluorides. Okay, that is why it is named as oxygen fluorides. Okay, it is named as what? Oxygen fluoride, not as a oxygen fluorine. Okay, the compounds of the oxygen with the other halogens are also known as oxides. If you consider only the fluorine, and the fluorine reacts with oxygen, we call it as oxygen fluoride. With other halogens, if you consider, it is generally known as what? Oxides. Okay, the halogen and the oxygen do not combine directly with each other. However, this compound will be formed indirectly. You can see that all these elements where the fluorine, which shows the -1 oxidation state with the oxygen. Okay, similarly you can see that the chlorine, okay, the chlorine from +7, +4, +6 and +7, you can see that oxidation state will be varies, and this is also forms what? Oxides. This is usually known as oxygen fluorides. This is oxygen fluoride and this is known as oxide formation. Similarly, you can see that bromine, which shows 3 different kinds of oxidation state, that is Br2O, BrO2, BrO3. Similarly, the iodine, if it is combines with the oxygen, it forms a +3, +5 and +7 oxidation state, and it is I2O4, I2O5 and I2O7. Okay. These are the reactivity towards the oxygen. So when they react with oxygen, they form oxides, but especially we see with the fluorine, it is generally known as what? Oxides of fluorides. Next, both OF2 and O2F2 are the strong fluorinating agent, and hence O2F2 oxidizes the plutonium to the plutonium F6. Okay, and in the oxides of the chlorine, bromine and iodine, the oxidation state will be ranges from what? +1 to +7. As we have seen with the chlorine, bromine and iodine, their oxidation state will be vary from +1 to +7 except fluorine. Okay, and the stability of the oxides of the halogen generally decreases down the group. Okay, so you can see that the iodine, chlorine and bromine, and the higher oxides are more stable than the lower oxides. And coming into their chlorine oxides, okay, the chlorine are highly reactive and it is generally known as what? Strong oxidizing agent. And the oxides of the bromide are least stable, and the halogen oxides are exits only at a room temperature. Hence, this is also known as strong oxidizing agent. Both chlorine as well as the bromine, they are known as what? Strong oxidizing agent. And coming into the oxides of the iodine, okay, it is insoluble in solid but decomposes upon heating and gives rise to the O2, O5, and this is also a very good oxidizing agent. And all the oxides of the halogens are mainly covalent in nature due to the small differences between the electronegativity of the oxygen with the halogen. Due to small differences with their electronegativity, they form some oxides with the other halogen. O2F2 will be does not form the oxo acids, as I have explained. The oxygen, when it is combined with the fluorine, it forms a oxygen fluorides. Thereby fluorine will exhibit the -1 oxidation state, and it is generally do not call it as a oxo acids only. And oxides of the halogen are acidic in nature, thereby it forms a oxides with water. Next is reactivity towards the metal. The halogen, when it is react with the metal, it forms a halides, and generally it will be in this order, that is metal fluoride, metal chloride, metal bromide and metal iodine. Hence stands for the metals. Okay, it may be metal or it may be non-metals also. You can take the example of sodium combines with chloride to form a sodium chloride. Similarly, you can take magnesium combines with the chlorine, forms a magnesium chloride. Okay. Aluminium combines with the chloride to form aluminium chloride. The halides of the higher oxidation state will become more covalent, and the one with the lower oxidation state. This is how, when this halogens combines with the metal, it forms a metal halides. Next is chlorine. So next to the fluorine, and the next elements in this periodic table is chlorine. So remember, both chlorine and fluorine, which shows different characters as that of the rest of the elements in this group. Hence, this chlorine and bromine will be kept under the anomalous behavior. Okay. So we know that the chlorine was first discovered by Scheele in 1774, and he has discovered this chlorine by the action of manganese dioxide with HCl. Okay. And the elementary nature of this chlorine was established by Davy, and he named as a chlorine on the account of greenish yellow color. On account of what? Greenish yellow color. Here you can see that in the green word, the coloras means grayish or greenish yellow. Okay. So who discovered the chlorine? It was first discovered by Scheele in 1774, and later the elementary nature was discovered by Davy. Okay. Coming into their preparation, we'll see how we can prepare the chlorine. Okay. By heating, already I have told you that it can be prepared by the actions of HCl on the manganese dioxide, right? So, by heating the manganese dioxide with a concentrated hydrochloric acid, we can prepare the chlorine gas. This is a manganese dioxide with a concentrated HCl. What does it form? It forms a manganese dioxide with a chlorine gas and with the water molecule. So this release of the chlorine, which confirm that by using the concentrated HCl as well as with the manganese dioxide, we can prepare the chlorine. However, the mixture of common salt with the concentrated H2SO4 can also used to prepare the chlorine gas. You can see that we have taken the sodium chloride with the manganese dioxide and H2SO4. You can see that the formation of manganese chloride with the sodium bisulfate and water molecule. Along with this, you can see that there is a release of chlorine gas will be formed. Okay. By the action of HCl on potassium permanganate also, we can easily prepare the chlorine gas. You can see that potassium permanganate, which has been treated with the HCl, it forms a KCl, that is potassium chloride, and manganese chloride. Water molecules will be released, and similarly the chlorine gas will be released out. This is how we can prepare the chlorine by using a different method. We have two more methods for the preparations of this. The first one is Decon process. In this process, again we are going to prepare what? Chlorine. So the oxidation of chlorine gas by the atmospheric oxygen in presence of copper chloride as a catalyst at 723 Kelvin, it gives rise to the chlorine. So what we are doing? We are doing the oxidations of hydrochloric acid in presence of copper chloride as a catalyst at very high temperature. It releases the chlorine gas with the formation of water. This process of oxidizing the HCl, which is known as what? Decon processes. And we have one more method, that is electrolytic processes. In this method, we are taking the concentrated solution of sodium chloride, okay, which is nothing but a brine solution. Okay, we are taking what? Concentrated solution of sodium chloride, and when you place the two electrode and if you apply the electrical field in the solutions, you know, it forms a sodium ion and a chloride ion, and in the electrolytic cell, which also consists of what? Water, that is OH minus ion as well as with the H plus ion. This chlorine will always release that at the anode. This process of producing the chloride gas at anode, it is also known as what? Electrolysis. More about this electrolysis we have already discussed in the electrochemistry unit. Next is chemical properties of this chlorine. Okay. First one is combinations with the metal. Let us see how does this chlorine combines with the metal and forms a respective compound. Chlorine reacts with the number of metals and all the non-metal except nitrogen, oxygen as well as with the carbon and noble gases. It can combine with the metal, it can combine with the non-metals also, thereby it forms a respective compounds. Remember, it does not react with the carbon, noble gases, oxygen as well as with the nitrogen. Okay, that is the exceptional cases. Coming into their affinity, okay, it has great affinity for hydrogen, thereby it decomposes many compounds and giving rise to the HCl. You can see that if the hydrogen sulfide which has been treated with the chlorine gas, thereby it shows the affinity towards the hydrogen and it forms a HCl with the release of sulfur gas. Okay. Similarly, reactions with the ammonia, it is very important for the examination point of view. Okay. So, in the examination point of view, hope you know that in the examination, most of the questions will be given in such a way that you need to identify the product which has been formed. So, in that part, you know, from the P block element, any three reactions will be given to you. You need to write the end product of that reactions. For each reactions will carry 1 mark. In that questions, you know, maybe from this part they can ask you the questions. Okay, how does they ask? I'll tell you. So, it is a reactions with ammonia. How does a chlorine gas will be reacts with ammonia? It gives the nitrogen and ammonium chloride with the excess of ammonia. When the ammonia is reacted with the chlorine, in such a way, it forms a two different product. I'll show you how does. If you take the excess of ammonia and if you allow to react with the chlorine gas, it forms a ammonium chloride with the release of nitrogen. Similarly, if you take the excess of chlorine gas and if you react with the ammonia, it forms an explosives which is known as nitrogen tetrachloride and along with the release of HCl. Similarly, these two reactions which look same, but ammonia you are taking in excess quantity, but here you are taking the chloride in excess quantity. In the exam, they can ask you to write NH3 plus Cl2 give rise to the NH4Cl plus dash. Like this they can ask, or else they can also ask like this, NH3 plus Cl2 give rise to the dash plus dash. Like this in examination they can ask you to write the end product, and it is very important to know that how does this chlorine reacts with the ammonia, that if it is there in excess quantity, if it is there in a small quantity, how does it react, that is very important. Next is reaction with alkali. Again this is a one more important reaction. See here, suppose if you are taking the chlorine which is allowed to react with a cold and a dilute alkali. We'll see how does the reactions will taking place. Okay. So, sodium hydroxide, if it is react with the chlorine gas, it forms a sodium chloride and also it forms a sodium oxychloride which is also known as what? Hypochlorite. Okay. So, with the release of what? water molecule. So again in the examination they can give the reaction like this, NaOH plus Cl2 give rise to what? NaCl plus dash plus water. Okay, like this the reactions will be given to you. Identify the product B, like that they can ask. Okay, if suppose the same reactions with the chlorine, if it is conducted with the hot and concentrated alkali, we'll see what is the product now. The same NaOH we are taking, that is hot and a concentrated NaOH. If it is allowed to react with the chlorine gas, it forms a sodium chloride and it also forms a chloride. So it is nothing but a sodium chloride will be formed with the release of water molecule. Same like this the question will be asked. So if you look at this reaction, even though you are taking the chlorine which is allowed to react with the alkali, if the alkali which is differs in their nature, the product formation which is also get differs. Okay, coming into the next reaction, that is formation of bleaching powder. We'll see how does the chlorine will be forms a bleaching powder. When chlorine passed over the dry salted lime, it forms a bleaching powder. How does you are taking the calcium hydroxide, if you allow to pass a chlorine gas, it forms a bleaching powder, that is CaOCl2 with the formation of water and calcium chloride. This indicates that during the preparations of bleaching powder, they'll use a chlorine. Next is oxidizing and bleaching nature of the chlorine. So the chlorine, we know that it is a very good oxidizing agent and also it can bleaches the salted lime, thereby it forms a bleaching powder, right? So the chlorine water upon standing for the longer time, it loses its color and thereby it become a yellow color due to the formation of HCl and HOCl, that is nothing but a hypochlorous acids. So hope you know that in the hospital they uses the chlorine gas as a sanitizing agent and they will keep the chlorine water for the more longer time. If it is kept like that, you know, the entire chlorine will become yellowish in nature due to the formation of HCl and HOCl. And this HOCl is unstable and decomposes to give a nascent oxygen. You can see that this chlorine gas, if it is reacted with the water, it forms what? HCl and also it forms what? Hypochlorous acid. This hypochlorous acid which is unstable, okay, it can further forms a HCl and also it releases a nascent oxygen. That is why formation of nascent oxygen from this chlorine, which is very delicate and it is responsible for oxidizing and bleaching properties of the chlorine. Most of the chlorine will behaves as oxidizing and bleaching agent because of the formation of nascent oxygen from the hypochlorous acid. Next is oxidizing action. So the chlorine oxidizes the ferrous salts to the ferric salts and it oxidizes the sulfite to the sulfate and sulfur dioxide to the sulfuric acid and iodine to the iodide. You can see that how does it acting like a oxidizing agent in the following compound. Here I have taken ferrous sulfate which is allowed to react with the sulfuric acid in presence of chlorine gas. What does it forms? Here the iron will be present in +2 oxidation state, thereby it changes its oxidation state to the +3. So it is a oxidizing agent and thereby it converts the ferrous salts to the ferric salts. Okay. Similarly, the sodium sulfate in presence of chlorine gas and water, it become a sodium sulfate. Okay. You can see that similarly the sulfur dioxide, which is a sulfite, okay, which is converted into sulfuric acid in presence of what? Chlorine gas. Similarly, if you take the iodine, which is get converted into iodic acids, you can see that iodic acid in presence of what? Chlorine gas. Thereby, all these reactions are indicating that chlorine is a powerful oxidizing agent and it oxidizes the many compounds. Coming into their bleaching actions, already we have understood that if you pass the chlorine gas to the salted lime, it forms a bleaching powder, right? So it is a powerful bleaching agent and the bleaching action is due to the oxidations of colored substances in presence of nascent oxygen, thereby it forms what? Colorless substances. You can see that if the chlorine is there, it reacts with the water, it forms what? HCl. Later, this HCl or HOCl you can say, which is undergo oxidations and forms a HCl, and nascent oxygen will be released. So, if you write this reaction, that is also okay, or else if you write Cl2 plus H2O give rise to the HOCl, that is hypochlorous acid. This hypochlorous acid in turn give a HCl or with a nascent oxygen. The presence of the nascent oxygen which has been formed in the chlorine, which is mainly responsible for bleaching actions in the chlorine. And coming into the uses of chlorine, okay, we know that the chlorine will be used as a manufacturing of bleaching powder. They will take this alkyd lime and they will pass the chlorine gas, thereby they will form a bleaching powder. And in the chlorides, hypochlorides, especially in the HCl and the chloroform, carbon tetrachloride, as well as in the DDT, we will use the chlorine as one of the major compound for the preparations. And in the purifications of drinking water, they'll add the chlorine. Hope you know that in the summer season, water, most of the time it gives a sensation of chlorine, and that indicates that they have added the chlorine for the purifications of the water. And in the bleaching of wood pulp and the paper, rayon industry, as a bleaching of cotton, especially in the textile industry, they'll use the chlorine gas. And in the extraction of the gold and platinum, as an oxidizing agent, as a germicide and disinfectant, it is generally we use the chlorine gas. For the preparations of many poisonous gases like a phosgene, tear gases and the mustard gases, we will use the chlorine gas. In the next session, one of the compounds of the chlorine, that is hydrochloric acid, that we are going to discuss in the next session. So, by this I like to say that what all things which I covered in this session, it is very, very important for the examination point of view. Have a look on it. We will meet you with the next session. Till that, take care, be safe. Thank you.